this was the one that is the entry level.
Yeah, this is kind of one of our mid-entry level models. This is a E346BA presetter by Elbow Control Nikken. It's a tabletop unit, 360 millimeter diameter range by 460 millimeter. It's about 14 by 18 inch. It's a very popular model because it's packed with a lot of really good features, things like our autofocus. So if you have something like a shell mill like this and you want to check every single one of these inserts, I can just bring the camera into the area, press a few buttons on the screen, and I can have this presetter check all of these inserts for me. So I can figure out if they're all on the same Z-plane, figure out where they are in diameter, figure out the maximums, minimums, things like that.
So shop calls wondering about what a presetter might do for them. Do you show them online, or do they have to see this in person to believe it?
So yeah, we get a lot of calls from people that have no experience with presetters. I mean, generally people are looking at a presetter when they're looking at increasing their efficiency. Presetter is an efficiency tool. It's used to be able to measure tools outside of the machine spindle. So I mean, kind of the traditional way is to use either like a touch probe that's inside of the machine, or a 1-2-3 block or something like that, which is a really time-consuming method, and you're using all of that time inside of the machine. So if you can prepare your tools ahead of time while the machine's still running, it's really an easy way to maximize your spindle uptime and just create more efficiency inside your shop.
So there's plenty of room for saving time.
Yeah.
Going from like the 1-2-3 blocks that somebody might be using that system now to using something like this, how much time do you think they save on average?
It depends a lot on the shop and how many CNCs they're running, how many tools they're changing out per day. But I mean, we've done some kind of studies where we're looking at the methods of measuring tools inside of the machine. With a really efficient in-machine touch probe, it can be as little as 30 seconds a tool. But if we're measuring 30 tools, say, that's 15 minutes of time right there. And if you're using a more, I always say just old school method like a piece of paper or a 1-2-3 block, it's a lot more than 30 seconds to measure the tool. So 30 tools can suddenly become 30 minutes or an hour, depending on the skill level of the operator. And then, the accuracy of that is also in question because, I might be able to measure a tool inside of our Haas out here with a 1-2-3 block and get one number, and you might do it and get a variance for sure.
Yeah, you might want to have someone double check it if I do it. So yeah, I mean, that brings up another whole question about type of skilled labor you have on staff. Someone's going to be faster at that than other.
For sure.
Someone who might be new or have no idea how to do that the old way. So okay, this then becomes something that a shop is interested in. What moves them from thinking about it to actually adopting one of these things?
So usually we like to do remote demos, kind of like what you were mentioning towards earlier. We do a lot of demonstrations over the web. We'll get a webcam in here and I can show people how it's going to be during someone using it live. I've even had customers send in their own tools if they have something a little more unique, so I can show them exactly what I would do when I'm measuring a tool.
Okay, and this is a tabletop system right here.
Yep.
So I mean, it's easy to see where it might fit on the floor of a shop somewhere. It's not really taking up a whole lot of room.
Yeah.
It might replace your coffee station, right? I mean, is that about the same size?
Yeah, we see guys putting these a lot of the time on top of toolboxes, on top of butcher block tables. We do have a stand available for it if you don't have something to put it on. Okay. But yeah, I mean, it's a very small footprint, and you can place it right on the machine shop floor. So, I mean, you could have it right inside of a cell of 5-10 machines, or you could have it in your tool crib. It can really go anywhere. A little bit earlier while we were talking, I was letting the presetter do the work. Here, just to show you a little bit of a difference, if I was going to do this manually, I would have to, take this spindle here and rotate each one of these inserts in and look at the measurement for each one. So, this shell mill here has 10 inserts on it, so that can be a significant amount of time for me to manually rotate that in, make sure I find that maximum point in rotation, and check every single one of these inserts and maybe adjust them in between, versus letting the piece of equipment do the work. So, I mean, it can be a huge time savings just not to have to be able to, manually find the high point in rotation for every insert on a tool like this. But it can also be a huge time savings if there's, say, lower skill level operators that maybe have never used a presetter before. If you let the presetter do the work and just kind of find each point automatically, they're not going to doubt themselves, or maybe they get some measurements and they look weird to them, and now they have to go find a manufacturing engineer. Where if we just let the presetter do the work, it's just telling us what it is.
And can you show me how if you were doing this manually and moving this to find all the points?
Okay.
You have to have a certain level of skill to do that, right?
It's a little bit of muscle memory, yeah. So, I mean, I have to bring the camera into focus so that I find the corner of the insert on this shell mill. And then as I do that, I'm going to start rotating this tool and finding typically the highest point in either the diameter or height, depending on what I'm looking for. So I'm going to be watching those readouts on my screen here and kind of rotating it back and forth and making sure that I'm finding that maximum position. Because it's really easy to just bring an insert in and, okay, yeah, maybe I think that's correct, but actually if I go in, there's like 7/10 more than I thought it was by just doing it real quickly and kind of sloppily.
Yeah, and what I'm looking at there is some people have a shake in their hands, sort of like me, and so from one person to the next, whoever might be working on that, there's a chance for there to be discrepancies between one operator and the next operator. So this takes away that difference.
Yeah.
It should eliminate it, from what my understanding.
Yeah, for sure.
The other thing that I think is what might be unsaid here is that some of the lost expertise on the shop floor is being absorbed and provided by the automation of this machine, and it's the way it's going for a lot of automation in the industry. Some of the need for that expertise on your shop floor in your personnel is being replaced by this, so that your operators don't have to have that 25 years of experience,
right,
or have to call the guy who retired 5 years ago.
Yeah, well, it's a good piece to kind of get people on the ground floor, in my opinion. So maybe I just brought in an operator who yesterday was working at a hardware store, at a car shop, or God knows where. I can train him and say, okay, you just started today, I just want you to find the corner of this tool, press these couple of buttons, it's going to rotate around, and I just want you to tell me the maximum number. In a couple of weeks, once he gets used to the piece of equipment, he's going to be a lot more effective. He's going to start using other features on the presetter.
Sounds like it's also a learning tool at the same time.
I like to think so.
It's a training tool in a way. That is an interesting perspective. Are we going to take a look at a little bit more advanced?
So, Dennis, I wanted to show you kind of one of our more advanced models. This is a E46CX. This is a full CNC presetter, so the X and Z and the C-axis for the spindle are all motorized. And we also have our automatic tool recognition installed on here. So this type of presetter is really geared towards more complex forms of tools, where we have multiple steps, multiple edges. And this is really easy to program and really easy for a basically untrained operator to use. So I can just train someone to press on a button here and scan this tool with our automatic tool recognition. It's going to bring up any jobs that the tool is involved in. I can select which one I want, put the tool in, clamp it down, and then it's just a one button press, and the presetter is going to move into position, and it's going to measure 3 different steps on this tool, and it's going to tell me, I've applied some tolerances on here, so it's going to tell me if some of these edges are good or bad without me having to look at a print for the tool or anything. So, I mean, just in the matter of pressing, I think 3 buttons there, pretty simple.
And it's probably almost done.
It takes a little bit of time. It's got to do a little bit of rotation there. It does slow down when it's actually taking a measurement to ensure accuracy, but then you can see like right now where there's nothing in the screen area, it actually speeds up that rotation to save time.
Your choice, which application or which job you were going to run this with, is that something that every shop, they might have 5 different, like, I guess, routines that they haven't used that tool for.
Okay.
And so they might have a different set of options when they go to this tool. Is that, I mean, just so I understand it, and
Yeah.
I want to make sure that if I'm, going to be explaining this to anyone else, that I understand they can have as many different options as they need programmed into there.
Yeah, so typically it's sorted out by what jobs that the tool is involved in.
Okay.
We can definitely do separate routines for different jobs. I mean, I could set this up so that it just measures one point on the tool, or maybe I want to have a separate routine for inspecting every edge of the tool, for a first inspection when it first comes into my plant, to make sure it's good.
Okay.
But maybe after that, I only care about taking one measurement because that's all I need for my CNC. So I can do it as part of an inspection program, or, potentially just get a X and Z measurement for my program on my machine.
Okay. And that, it kind of ran through its thing there.
Yeah, so it ran through its thing, and it's showing 1, 2, 3 here. These are the 3 different edges that it measured. And then if I open up one of those, I can see the X and Z measurements for that specific edge. And then if you look here on this diameter, I applied a tolerance to it. So this dotted line would be our nominal, and then that green bar would be the tolerance that is allowed for that edge. And then, both of those bars are inside of there. If one of them was not, then it would show up as being a big red bar, and this X value would be flashing at me, telling me something's wrong. So it makes it really fast and easy, especially if it's, like a custom tool that I'm bringing in to make custom parts. A lot of people need to have those inspected before they get them out to the shop floor, to scrap saving feature.
So you just mentioned if it is flashing red. So how would it help you figure out what to do if it is flashing red? What would, like for instance, you don't have to
Sure.
demonstrate that,
Oh,
but.
it's easy enough to show.
Oh, okay, go ahead.
So, let's say if this edge right here was out of my tolerance, I can just press right there. The presetter is going to bring me back to that position that it measured. I can minimize this, and then I can inspect it either with just looking at the shadow here, or maybe I'm going to use our inspection camera. Maybe there was just a piece of hair or dust on there, or maybe it was made incorrectly. So, at that point I can start to investigate why.
So in other words, if you're inspecting it to make sure it's up to your spec for the job, this is going to find out if it isn't.
Oh, for sure.
Okay.
Absolutely.
All right. Okay.
And then if I want to save any of that information, just right there. And then all those measurements I just took are saved in my tool table.
And there's also the whole identification. It's all this information will be embedded with this, with whatever this tool is being used to make, whatever part it is.
Mm-hmm.
That somehow there's going to be a digital footprint that follows about this tool that was used on whatever end product that it was being used to make.
Yeah.
That is not the best and most eloquent or articulate way of asking that question, but I think you know what I mean.
I think you got the point across pretty well. Yeah, I mean, we're identifying, in this case, the tool with a data matrix code. So that's why I'm using the scanner. So each tool is kept track of in a database just by scanning that data matrix code on there. It's just an identifying number, essentially. We can keep track of what jobs this tool is being used in. We can keep track of this tool's location within our workshop. We can actually use that even to send offset data to the CNC, so we don't have to worry about people fat fingering in numbers, provided everything's networked, of course.
Yeah, and the reason I mentioned that at all was there is an increasing need for that. For any shops working with aerospace or defense especially, I think even obviously for medical devices that somebody might be working on, that's becoming a requirement at this point.
Yeah.
So.
Yeah, I mean, keeping track of the tools is, especially in the situations you named like aerospace and defense, we got to know where everything is all the time and what it was used for. And
what size shop would be good and to take one of these on? At what point should they seriously consider moving to something like this, I guess?
I mean, I think, I'm obviously a little bit biased in saying that I think every shop should be using one. But I mean,
at this level.
Oh, at this level?
Yeah.
It kind of depends on for this level of presetter, it kind of depends on the styles of tools you're using. This is near the top end of our product range for technology. Now we have, if someone's using more common tools, just end mills, drills, reamers, taps, those kind of things, we've got better solutions for people that aren't using crazy complex multiple step tools. But I mean, it really depends on what kind of tools you're using. So I mean, you might be a small shop that works with a lot of custom geometry tool or form tools where you want to check those, weird shapes of the tool, then that's where something like this would come into play. If we're more standard job shop manufacturing where we're just using those more common tools, there's more mid-level options for that.
Okay. And that's probably helpful for shops out there that are like wondering. I mean, if they don't have any kind of automated presetter of any kind, then more than likely that's maybe the entry-level desktop model back there.
Yeah.
I
mean, we have automated models that are more geared towards those common tools too.
Okay.
Where we're just not keeping track of quite as much information about the tool. If we don't have 6 different steps or 3 different steps on the tool, we don't need to keep track of that, right?
Okay.
We don't need to overcomplicate things.
What are some of the customers that make this investment? What are they surprised by? Do you know? I mean, what's the thing that they come back and go, I didn't expect this? Or
usually it's ease of use. Once we've installed it and trained their staff, it's usually a very quick time frame for them to adopt something like this. And there's a lot more inspection features where we can look at things like angles and radii. We can even create a DXF of this tool or overlay a DXF on the presetter, where people might just be thinking about, I just need to measure my tools to get a Z value for my tool table, and they don't necessarily realize that there's a really powerful inspection camera here where I can look at that insert. And I can also look at what's the size of the corner radius, what's the angle of this chamfer mill, there's a lot of features packed into here that people don't necessarily think about with a presetter.
Opens the door to so many different possibilities for a shop. How long have you been with Lyndex, and how did you get involved with it?
Sure. So I've been working for Lyndex for about 10 years now. I came from outside the manufacturing industry. I was kind of telling you earlier, when I was in high school, we had a machine shop in my high school. And it was all manual equipment, really old World War II era Bridgeports and things like that.
And you graduated in 2005, you said, right?
Correct. Yeah.
Okay.
Yeah, 2005.
So World War II era.
I mean, maybe they weren't that old, but I mean, that was kind of the impression that I had when I was there, being a young kid. And I really enjoyed it. I've always liked working with my hands and making things. And but everything that I heard, when I was in school was, that American manufacturing is all overseas and just stories about the Rust Belt and, it's kind of a, dying thing or whatever. So it wasn't really something that I would think that would be a good career for me at the time. So I went and I got myself a degree in IT support. I worked in that for 6 or 8 years, and I ended up landing here at Lyndex. And,
in IT support?
I actually got started doing some really basic engineering customer support, because I had kind of that customer support background from the IT job that I was working in. And I ended up doing a lot of growing here. I mean, it was a great opportunity for me to learn and grow, and I just really enjoyed doing it. I ended up learning how to longhand program on our CNCs. I ended up, shortly after that, learning how to program in CAM software, and then ended up becoming the presetter product manager over the course of 10 years. So.
And how long have you been the presetter product manager?
Less than a year now. I've been working with the presetters since about 2018, but just within the last year or so, I've become the presetter product manager.
So your beard is older. What you said about your time in high school in the shop class, what was it about that machine shop class that you liked?
Like I said, I've always liked working with my hands and making things, and I always just thought it was cool. I mean, you're cutting metal.
Yeah, did you make something that you might still have?
I know I made a hammer, and I'm pretty sure I still have it.
Oh.
We had a 4-prong. We called it metalworking class, and it was a 4-prong class. So we did a little bit of machining, we did a little bit of sheet metal work, we did a little bit of foundry work, and we did a little bit of welding. So I know I still have an aluminum anvil that I cast.
Wow.
And I think there's a shelf at my sister's house that I welded up.
And it's still up.
Yeah.
That's good.
Might not be the squarest thing in the world, but.
The appeal that machining had for you, it was your own impression about what people were telling in your circle at that time. Did that circle include parents? Who was telling you about the Rust Belt and saying it's kind of not the good direction to go?
I don't remember exactly any specific person saying like, oh, you shouldn't go into manufacturing. Like, I enjoyed the shop class a lot, and like I said, I enjoy working with my hands making things, but I grew up in the Kenosha, Wisconsin area. The whole time that I was growing up, we had a Chrysler plant in Kenosha that was in the process of shutting down for decades. It used to be American Motors, so I think it was just kind of a community perception that I had of just things kind of on the decline, that maybe American manufacturing was not necessarily a growing industry that I wanted to get myself involved in. So, at the time, IT was really starting to boom, so that's where I aligned myself, making sure that I'd be able to find a job. And
that's interesting because that was the decade where China actually overtook the U.S. for being a global manufacturing powerhouse. That was definitely a well-known view at that time. So it's no surprise that that's what you picked up on that. So again, not being very articulate here, but if you had been encouraged anywhere along the way, would it have made a difference to you to follow through and stick with that as a career choice back then? Or do you think at this point in your life, does it even matter that the one thing that I think here that's interesting is that you even had the exposure to a shop class at that point. And it doesn't sound like they ever got rid of the shop class at your school.
As far as I know, it's still there. I'm not 100% sure. I don't know if it would have made a difference, but at this point in my life, I consider myself extremely lucky to have gotten back into doing something that I thoroughly enjoy. I really didn't enjoy sitting in a cubicle and answering a phone about Windows problems or whatever it was. But I mean, I'm a huge proponent of encouraging younger people to get into the trades, whether it's manufacturing or electricians, carpentry, plumbing, whatever it is. I mean, I think I'm a perfect example that maybe a 4-year school isn't for everyone. I just have an associate's degree here, and I think that if I would have gone to a 4-year school, I probably would have not done so well and maybe partied a little too hard back then, those kind of things.
Certainly, depending on the school you go to.
Yeah, it's not the right track for everyone, in my opinion.
Well,
and there's a lot of opportunity out there for people that work with their hands or have skilled knowledge, for sure.
I'm kind of curious. Lyndex has a continuing education benefit of some kind for employees. I'm not sure if that's something you can talk about.
Yeah, so I mean, we've definitely here at Lyndex done some, I don't know what the word is for it.
It's all right.
Not necessarily a scholarship, but covering education costs for some of the employees. I personally took a few classes after I started here, just almost as a formality. It wasn't a requirement or anything, but going to a local tech school and just taking some basic machining classes, which kind of at the point I was already working here, I was maybe a little bit more advanced than some of the entry-level classes, but either way, it's a good benefit to be able to say that I've gone and I've gotten these certificates or I've taken these classes, and it's a huge benefit that Lyndex supports people continuing education like that.
Potentially middle school and high school. What would you say to them about, like, if you're unsure of college and what path you're going to take, how would you advise them to consider a manufacturing career? And what aspects of a manufacturing career would you kind of inform them about?
I mean, there's huge opportunity to learn on the job in our industry, I think. And you have to pay attention and apply yourself and be willing to learn every day. Like, it might not be textbook learning, but you're going to learn something every single day in this industry. It's constantly changing, and I don't want that to be intimidating.
Yeah, I was going to say, when you say you got to come to work ready to learn every day, there's a difference between going to school every day and being expected to learn something new every day versus going onto, let's say, a shop floor and machining something and having to keep up to speed with whatever the technology is to be as productive as possible. Because when you're producing something, and you're figuring out a way to improve that process to make it more productive, more efficient. Just watching the chips fly, you become more invested in doing what you're doing now. So can you get into that a little bit?
There's a level of pride or just a level of accomplishment at the end of the day when you can hold something in your hand and say that I made this. Whether it's part of a sink faucet or part of a freaking fighter jet. You never know what you're going to be making in our industry. And I made this as best as I possibly could. Maybe you're going to make it better tomorrow, but you're always increasing your personal skill level by doing the work better every day and by learning. There's a lot of really experienced people in our industry that I've learned from that, like I said, it's not textbook learning. It's maybe, hey, I had this problem when I was doing this, and someone more experienced than you helping you out and teaching you this. It's just drawing from all these different sources to learn, and then at the end of the day, you're always going to have something to hold in your hands and say, I made this. And there's just a huge personal pride, personal accomplishment, whatever you want to call it in that, in my opinion.
And your personal experience, how good has this career change been for you?
Oh, huge. I love it. I get to learn something every day. I get to see new things all the time. I wouldn't choose anything else.
And you like being the product manager for presetters.
Yeah. I mean, I get to visit shops all over the country, all over the region, and see how they do things and teach them how to do things better, learn from them at the same time. It's huge for me.
So do you do any of the training? What do you lead those? Any of the like the College of Lake County, the students?
I have in the past, yeah.
Do you like doing that part of it?
Yeah, I mean,
I mean, I think you said you did some of that customer service thing in IT, but is that the same kind of thing, or is that?
it's a lot different when you're standing in front of someone and you're teaching them how to do something. You know, it's kind of like holding that part in your hand at the end of the day. It's, you know, if I can teach you how to do something better or more efficiently, or teach you new skills, and at the end of the day, you understand how to do your job better, and that's great.
No, that's very cool. Well, thanks. I like exploring as much as I could to get your take on manufacturing careers, because that's what I've decided. Our magazine has to help this industry change the perception.
Yeah.
And it's not just by talking to our industry. This is where social media is going to come in. We're going to start sharing a lot of this discussion on Facebook and every other place, because that's where a lot of the misconceptions are out there still to this day.